So today we do problem on time and work. Time and work as a chapter has various kinds of problem. We'll see all the types as we move on with the different videos. We'll start with the basic time and work problem. Then we'll move on to man-day hours problem. Then from that pipes and systems and the problem on efficiency. And that's how I'll complete the chapter on time and work. Okay. So let's start with the first type, which is normal time and work kind of problem, where a scenario is given to you and you are being asked a solution to it. Okay, now even the normal time and work kind of problem have two methods to it. The first method is called as the LCM method, which we will use it right now. So the first video will tell you about the LCM method, which you will use it most oftenly to come to the solution of such kind of problem. And then the second method, which you will find in mostly all the books that you solve, which is called as the reciprocal method. But we don't prefer the reciprocal method because I personally feel that the LCM method is much better than any other method to solve time and work problem. So what is a problem here given to be? Now this wall, we need to make this wall, and how do you make this wall? You can make this wall simply by putting up bricks in the wall. Okay, so don't imagine cement and everything. So if there are say 30 bricks, I have to put in 1, 2, 3, 4, say any number of bricks. For example, say 30 bricks I have to put in. If I put in the 30 bricks, the wall is being made. Who all are making this wall? Now this is just an example. Okay, instead of 30 bricks, take 60. How many bricks will we take? I'll tell you in the next part, but just put in the bricks and the wall is made. Now who all are working to make this wall? Ramesh, Suresh and Mahesh. As you can see here, Ramesh, Suresh and Mahesh. And what is given to me? Ramesh working alone can build this wall in 5 days, which means if he is working alone without the help of anyone else, he can make this wall, which means he can just put in the bricks and make this wall in 5 days. Similarly, Suresh working alone, which means without the help of anyone else, working alone can make this wall in 10 days. This is also given to me. And Mahesh working alone, okay, again working alone without the help of anyone, he can make this wall, which means put in the bricks in this wall and make this wall in 15 days. Now the question that is being asked to me is all three are working together, which means Ramesh, Suresh and Mahesh, all three are working together. Okay, so the question now here is how many days will be required to make this wall if all of the three are working together? Now I don't know maths, but I know logic. And what does my logic says? Ramesh working alone can make this wall in 5 days when he is working alone without the help of anyone. Now when they are working together, actually Suresh and Mahesh, you can say, is helping your Ramesh. If they are working together, you can say Ramesh was working alone, he was doing it in 5 days, working alone. Now he is helped by Suresh and Mahesh, as all the three are working together. So the number of days that will be required will be lesser than 5. Correct? Will be lesser than 5. Why? Because he was working alone and doing it in 5 days. Now with the help of Suresh and Mahesh, the number of days will be lesser than 5. That is what logic says to me. Okay, forget about maths here. That is what the logic says to me here. Now that's what I'll do. Okay, I'll start thinking what will be the number of days lesser than 5. So what is the method? First method is called as the LCM method. Now first you have to think, okay, how many bricks will they put in to make this wall? You don't know now how many bricks will you put in to make this wall complete. You can start with any number, but I want to start with a number so that my calculation becomes easier. You can say there are 10 bricks in a wall, so I can start with that. If 10 bricks are being put in, wall is being made. You can start with, say, there are 20 bricks. If you put in 20 bricks, wall is being made. That is your assumption. Take any number you want to. Okay, you will always get the answer, but I'll take a number which is making my calculation easy. So 5, 10, 15. Where did I take this from? This 5, 10, 15. Ramesh, Suresh, Mahesh working alone days. I take it here. I take the LCM of this 3. Okay, what is LCM? Least common multiple of this. And how do you start with this? If you don't know, go to the numbers chapter. I had explained it there. So start with the largest number, that is 15. Take 15 ones are 15. Okay, that is not the multiple of 10. It's a multiple of 5, it's not a multiple of 10. 15 twos are 30. It's a multiple of 10, it's a multiple of 5 as well. So start with the highest number, check its multiple, check if that is also the multiple of the next two number as well. So 30. So I'll take 30. Okay, what is the meaning of this? If 30 bricks are being put in, this wall is being made. Okay, as I told you, take 60, take 120, take 90, take any number, you will always get the right answer. Why am I taking 30 bricks? Because my calculation will be easier. So what is the meaning of this? If you come here and put in this 30 bricks, something like that, you put in 1 brick at a time and you put in 30 bricks, this wall will be made completely. So Ramesh, working alone, can put this 30 bricks in 5 days, right? Because he can make this wall in 5 days, so he can put in this 30 bricks in 5 days. So can you tell me, per day, how many bricks will Ramesh put in? That's quite a logic. 6. He will put in 6 bricks in 1 day. In 5 days he will put in 30 bricks, and he can make this wall all working alone. Suresh can put this 30 bricks, make this wall working alone in 10 days. So can you tell me, per day, how many bricks will he put in? 3. 10 into 3 will be 30. And Mahesh, working alone, can make this wall in 15 days, which means he can put in 30 bricks in 15 days. So per day, how many bricks will Mahesh put in? 2. Okay, and making the wall is just about putting up the bricks. Now what did I tell you? All the 3 are working together. So what will happen now? Ramesh will be putting up 6 bricks, correct? Suresh will be putting up 3 bricks, correct? And Mahesh will be putting up 2 bricks, correct? So total number of bricks that will be put up by all 3 will be 11. 11 bricks will be put in 1 day when all the 3 are working together. How many bricks are you supposed to put in to make this wall? 30. If you put in 30 bricks, the wall will be made. Okay, and Ramesh, Mahesh, Suresh working together in 1 day can put in 11 bricks. So how many days will be required to put in 30 bricks? Okay, so the answer to this will be 11 ones are 11 twos are 22. Then what are you left with is 8 by 11. Now what is 1 by 11? 9.09. 9 into 8, 2.72. That's it. That should be your answer to this question. As I told you, the logic said it to me at the start. It should be lesser than 5 days. Yes, it is lesser than 5 days. It is 2.72 days. So when all the 3 are working together, 2.72. Now you will imagine, sir, how can the days be 0.72? So 2 complete days, which means they will put in 22 bricks in 2 days, and they will require 8 by 11 of the third day. Which means they will not require the complete third day. They will require just 0.72 part of the third day. So if the assumption is they are working for all the 24 hours, take 72% of the 24 hours. That will be 0.72. Okay, so that's how you solve the problem of basic time and work with your LCM method. So in the next video we'll see the same problem, but we'll see how do you solve it by reciprocal method.